You're told that the formula for the volume of a sphere is 4/3 pi r cubed. R is the radius of the sphere. And you're told that the radius of a particular ball or sphere has been measured to 3.5 centimeters, but only to the nearest tenth of a centimeter. And we need to find the upper and lower bound of the volume. So to start off with, we have this radius of 3.5, and we need to think about what is the upper and lower bound if it's been rounded to the nearest tenth of a centimeter. And that would be to 1 decimal place. This is the tenths column. So that would be 3.45 or 3.55. So if it was 3.45 and we were rounding it to 1 decimal place, it would round up to 3.5. And if it was 3.55, technically it would round up to 3.6, but 3.499999 would round down to 3.5. So we tend to use the 3.55 as the marker for the middle point. So to find the upper and lower bound of the volume, the lower bound is going to be using the smallest radius, because that's going to be the smallest sphere or ball. So that's going to be 4 pi times the radius, and I'm going to choose my lower radius, cubed, divided by 3. And if I type that into my calculator, I get 172.007, or to 3 significant figures, 172 centimeters cubed. And then my upper bound, this time I'm using my upper bound, so that's 4 pi times 3.55 cubed divided by 3. And again, if I use my calculator, that gives me 187.402, or to 3 significant figures, 187 centimeters cubed. So my lower bound is that it would be 172, and my upper bound is that it would be 187. And then the second part of this question is similar. So the second part is I have another sphere and the volume is 500 centimeters squared. So this time the volume is 500, and we know that that's measured to the nearest 10 centimeters. So we need to think about what the upper and lower bound is. So if it's to the nearest 10 centimeters, we halve that, which is 5, and we go 5 either side. So that's 495 and 505. And we can just think that through. If I had 495 and I was rounding it to the nearest 10, then that would be 95 rounds up, so it would be 500, which is right. And then 505 is the next kind of boundary, which would round up, but we use it as our boundary for our upper bound as well. So for this one, we know that the volume is either 495 to 505. And we're trying to find the radius. So we need to think about rearranging this. So to calculate the lower bound, I'm going to have the volume, and again I'm using that same formula, but this time I know the volume. So the smallest volume is 495, and that equals 4 pi r cubed over 3, and I'm trying to find r. So this time I can actually do this rearranging on my calculator. So I'm going to go into, if I come out of this, I'm going to go into math and numeric solver. I have 495, and I have, if I clear this, 4 times pi, so second function and this up arrow, times, and then it's r, which I'm going to call x to the power of 3, and that whole thing is going to be, so I'm just going to put brackets in, so I'm just going to insert brackets at the start here. So that whole thing is divided by 3. And OK, and solve. So my upper bound there is 4 is r is equal to 4.907, or to three significant figures, 4.91 centimeters cubed. So I have here 4.91 centimeters cubed. And now I'm going to do the same again, this time for my upper bound. So for my upper bound, this time the volume is 505, and it's equal to 4 pi r cubed over 3. And again, I'm going to need my calculator to find what that might be. So math, numeric solver, and it's 505. Now I can actually leave my formula as it is on the left-hand side because it's the same. So okay, and solve, and it's 4.940. So R is equal to 4.940, which is approximately 4.94 centimeters. Okay, it's let me get rid of the cubed. There we go, it's a length, so it's just centimeters. Okay, so if we go back, we can see that I've got two possible answers that it lies between, 4.91 and 4.94. So my radius must be between one of those values for the volume to round to 500 to the nearest 10 centimeters.